Divide 15 into two parts such that when the larger is divided by 3 and the smaller is divided by 2, the quotients are equal. So like the previous question, we're going to take the 15 and we're going to divide that into two parts where it's the larger is divided by 3 and the smaller is divided by 2. And the key is that the quotients are equal. So we're going to do the same thing that we did in the previous question, which is define the variables. Step 1 is let x represent the larger number. And we're going to let y represent the smaller number. We're going to have the two parts. We're going to have two equations. The very first equation is going to be x plus y equals 15. Those are the two parts. And equation number 2 is going to come from the statement that the larger number is divided by 3. So that would be x divided by 3. And then it tells me that the smaller is divided by 2. That gives me y over 2. And finally, these two quotients are equal. So I'm going to set them equal to one another. So I have a linear system again with two equations and two unknowns. So as I did in the previous example, I am going to use substitution. And in this case, what I am going to do is I'm going to isolate the x in equation number 2. So where I have x divided by 3 is equal to y divided by 2, what I am going to do is I'm going to multiply both sides of the equation by 3. So when I multiply this side by 3, and I multiply this side by 3, the two 3's on the left side will reduce to 1. They don't cancel, they reduce to 1. Then you get x on its own isolated, and on the right-hand side, you get 3y divided by 2. And this is what I'm going to substitute into equation number 1. So sub x equals 3y divided by 2 into equation number 1, and we are going to solve this. So if I look at equation number 1, x plus y is equal to 15. I am going to now take this x, and that is what is going to be replaced with 3y over 2. y over 2 plus y is equal to 15. I have a fraction now. With the fraction, I need to have a common denominator to add. And the common denominator is if I'm going to have a 2 on the denominator, I have to multiply the bottom and the top by a 2. Once you get that, you will have 3y over 2 plus 2y over 2 is equal to 15. I can add the numerators together to give me a 5y divided by 2 is equal to 15. At this point, I'm going to multiply both sides of the equation by 2. And these two 2's are going to reduce to 1. I'm going to be left with 5y equals 30. I'm going to divide both sides by 5 now to isolate the variable. When I divide both sides here by 5, once again, these 5's reduce to 1, and I'm left with an answer of y equals 6. And if you recall, y equals 6 was the smaller number. I'm going to take this answer now, and I'm going to sub y equals 6 into equation number 1. You could put it into equation number 2, but equation number 1 is the easier equation, where it's x plus y is equal to 15. So I'm going to substitute x plus 6 equals 15. X equals 15 minus 6 because I'm subtracting 6 from both sides of the equation. And I'll have an answer of x equals 9. Step 4 is to do my check. And the check is the 2 parts. My 2 parts are 9 and 6. Do they add to give me a 15? Check, yes. My second part is that when I go back and take a look, it tells me that the larger number is divided by 3 and the smaller number is divided by 2. So we're going to come back down. The larger number is 9. I'm going to divide that by 3. I get an answer of 3. I'm going to take the smaller number, which is a 6, divide that by 2. I get an answer of 3. So when I take a look, are these two quotients equal? The answer is yes. Now, step number 5 is you write your concluding statement or your conclusion. And that is, therefore, the larger number is 9, and the smaller number is 6. Finished.